this is Jonathan Bonkoske, EPC Electrical Power and Controls Instructor for TSTC here in Fort Bend. We have an awesome crew of Texas A&M students here visiting us who've just been through 9 weeks of a mechatronics automation course. And the final project that was put together by all of us is a proof of concept of a slot car drag race set, implementing industrial automation controls along with it. And let me take you on a ride through this whole entire project. And this has been a fun project with a lot of skills being implemented, not only with playing with slot cars, of course, but also introducing programmable logic controllers, something like these little critters right here, which is a consumer grade of a click PLC. That's it doesn't cost much at all. And also implementing sensors, light detection sensors for our finish line right here, and also way down yonder, our starting line. So there's a lot of skills being implemented with this type of a setup. This is a proof of concept. This is the first time we're doing this, and this is going to live on through our program, and also robotics and electrical power controls. And we're going to keep this alive, modifying it, improving it, and building experience, and that's the whole part of it. So let's take you on a little ride through this thing here. So what we have is we have the starting line and finish line. They all have sensors, lighting, and of course the cars, and of course our drivers, and all that through here. We have another PLC right down here for our starting line PLC, which is this little critter right on the side. And of course it's a mess, so definitely forgive all the wiring, but this is design, this is development, this is proof of concept. And this takes DC power supplies, so we use concepts from DC, and as well as digital, wiring, and programmable logic controllers, and also building the program. Is our program set up on here? And so we have, if we can get a shot of maybe the ladder logic program with something that's roughly used with this to input all the information from the sensors and output information, output logic signals. And we also have a box that we're using switches for to allow us to reset variables, reset data, and also to help the starting line get going. All of this is tied together. So we have two PLCs. This is all tied together in an HMI interface. What we have here is Advanced HMI, which is an open source HMI program that anyone can use, anyone can download. We bring information through RS-485 Modbus into the Advanced HMI, where every piece in here, lights, miles per hour, elapsed time, reaction time, that is all communicated into the HMI, just like an industrial system would for a process in a plant or whatever. So all of that gets tied into here, and then we can see it. We have it broadcast onto a bigger TV screen, and right now, instead of just building a Christmas tree, we decided to go ahead and put it into the HMI screen, and all of the lights, they come from the PLCs and light up accordingly through all the programming there. Now, some of this is still in development, and some of it works, some of it does not, but that's the whole exploration process of development and research and proof of concept. So our whole goal here is, number one, could we do this? Could we take something as simple as maybe a grown-up child's toy and implement it into our programs using industrial automation? And yes, it has worked. We have some circuit information, a layout drawn up on board here. And so we have a concept of what the HMI display looks like, and that was replicated very nicely. And we also have some of our interface schematic and circuit. And we have a light sensor here with an op amp and with some setup voltage set to be at a comparator to indicate to us on the output with an LED if a car is at a certain line on the track, whether it's pre-stage, staging, and also the finish line as well. They use the same interface circuitry. The output of this does go into an input into the PLC. That's how the PLCs, they know what's going on, and based on that, once they get their information and the programming, everything starts up. So this is a semi-automated process here, and if the drivers are ready, we would like to do a little demonstration. And again, you know, this is not a perfect situation. We're still in development on this, but we might be able to see some information pop up on the screen that it's used with communication. So we have a lot going on here, and we'll see how that goes. Okay, drivers, are you ready? We're getting pre-staged. Lane 1 is pre-staged, and then getting lane 2 staged. And the official will flip the switch, saying good to go. Okay, so we got something. We still have a few bugs to fish out of this system, and as with all systems under development, there's a lot of bugs. So, but we did get an elapsed time, a scaled top speed of maybe 75. I don't know. We'll have to see about that. We may have a car that's been modified to illegal specifications. We don't know yet. But anyway, this is the whole concept. Is to integrate into a project, a very large scope project, all the way from, you know, a simple piece, a toy, and put in industrial automation, controls, and valuable skills and documentation and so on. So I hope y'all find this interesting, and thank you for viewing.